Alright, so without further ado, it's a good idea to move to our next speaker, Erwin Staal. Erwin Staal is an Azure Architect and DevOps Consultant at 4Dotnet. He lives in Meppel, the Netherlands, and for the past 10 years he built up a lot of experience with both large enterprises and smaller organizations. And today he's going to tell you about ARM templates, and it's actually a deep dive, so it's really the nitty-gritty details that you'll learn here. So without further ado, let's go to Erwin.
Alright, hi everyone, welcome. Thanks for having me at this great conference. And as Eduard mentioned, we're going to talk about ARM templates in the next 45 minutes or so. So Eduard already did a proper introduction of me. I do need to rectify something. I do live in Assen, which is also a very beautiful city, but it's not Meppel. That's where we're actually based. But never mind. Alright, so I do indeed work for this beautiful company as an Azure architect. And today we're going to talk about ARM templates, so that means doing infrastructure as code on Azure. And if you're going to do that, no matter what approach you take to do infrastructure as code on Azure, you will always be doing that by talking to what is called the Azure Resource Manager. And the Azure Resource Manager is the thing in Azure that allows you to do deployment and management of your services. So it's the thing that enables you to create, update, manage your resources in the cloud. It's also the service in Azure that allows you to do role-based access control. So that means that you can dictate who can do what on what resources. And that's also part of your Resource Manager. Another thing it can do is that it can also allow you to apply policies. And with a policy, you could, for example, say that you only want virtual machines to be deployed into Western Europe and not in any of the other regions that Azure actually provides you. So that's also something, the policy stuff is also part of the Azure Resource Manager. And if you as a user want to talk to the Azure Resource Manager, then you have quite a few options to do that. And I'm going to talk just about the stuff that Microsoft gives you, not even about the third-party options you have. So if you want to talk to the Azure Resource Manager, you could actually do that direct using HTTP requests. It's just an API that you can actually talk to. But there are also quite a few other options. For example, you will probably be quite familiar with the Azure portal. That allows you to create all your resources and just click around, next, finish, and be done with creating a particular resource. But there's also various ways to do that from a scripting language like the Azure CLI or from PowerShell. And those three combined actually give you another option, which is called Cloud Shell. So this little icon in the Azure portal allows you to use both PowerShell and the Azure CLI from within the Azure portal. So you don't need to install anything locally. You can just go to the Azure portal and still use the Azure CLI or PowerShell to quickly do what you need to do. So next to that, there's the SDKs. And the SDKs allow you to manage your cloud services from many programming languages. So you could, for example, be deploying your resources using C# and do that from code. And last but not least, there is also a way to do that with templates, and that's of course what we're going to talk about today. So all of these types of interacting with the Azure Resource Manager allow you to manage your resources. And there's actually one that I'm almost forgetting about, and that's that there's also an app on your phone that you could also use to interact with the Resource Manager. But the Resource Manager itself isn't actually the thing that makes or updates your resources. That's been done by underneath the Resource Manager. So there's a resource provider for example, the networking stuff, and there's one for the virtual machine stuff, and there's a resource provider around web, so the Azure Web Apps, etc. And the resource providers in turn are the things that actually make the resources. But you can't talk to them directly like you can to the Resource Manager. So you always need to go through the Resource Manager, otherwise you would also opt out for policies and role-based access control. Alright, so then what are these ARM templates? As you can see in this very small example here, it's a way to declaratively write your infrastructure as code in a JSON type of language. It allows you to do central management of all the resources you have in Azure. And the deployments are idempotent, which means that if you would deploy a particular template 10 times, you would get the same end result every time. And that is sometimes different when using the PowerShell or Azure CLI, for example. So that's a benefit of the templates which you can use. Since they're just JSON files, basically, it's also quite easy to put them in version control and apply patterns that you would normally apply to your code. So you could, for example, do pull requests to have colleagues verify your changes, and you can easily deploy them using Azure DevOps, for example, which we will look at near the end of the session today. Alright, so when you start deploying a template, an ARM template, it doesn't really matter if you do that using the Azure CLI, or if you deploy the template from PowerShell, or if you deploy the template from Azure DevOps. You always deploy your templates at a particular scope. And these scopes in Azure allow you to group your resources into a logical organization. And at the top level, we have the management groups. And within a management group, you can find other management groups, or you can find subscriptions. And subscriptions in turn can contain resource groups, one or many. And a resource group then contains your actual resources. That's where your actual resources live. And so you get to do deployments on each of these levels. And so that's quite handy, because that allows you to manage your resources at different levels, different scopes throughout Azure. So you could, for example, say that the example on the policy I gave in the beginning on not being able to deploy virtual machines in any other region than Western Europe, you might want to deploy that policy at the top management group level, because that would actually apply that policy throughout your entire Azure organization. But you could also say that you probably want to deploy an ARM template that deploys some role-based access control on the subscription level. That would allow you to say that a particular team has full write and read access on one subscription, but doesn't have those same permissions on another subscription. And this is a hierarchy. So whatever you deploy on the management group level will also apply on whatever is underneath the management group level. So the same thing would apply to subscriptions, resource groups, and all the resources within them. You have the option to make exemptions on a lower level to work around that if it shouldn't be applied to a particular scope down in the hierarchy. So let's now go over to more demos, or actually we're going to move over to Visual Studio Code to actually show you what ARM templates are, what they look like, and the different things we can do with them. So let's start with the simple things in ARM templates. This is the basic layout of an ARM template. If you would do a file new ARM template, then this is what you will get. So the important bits here are the parameters, the variables, the functions, the resources, and the outputs. And we will quickly talk about them one by one. That's what I've called my introduction in ARM templates. And then we quickly move over to the more advanced and interesting stuff. And last but not least, we will look at a bit of a demo application that's a bit more real life. And I'll show you how you could do a bit more complex stuff in a real world situation. But let's start with the basics of an ARM template. So the first thing you probably want to know about is the parameters. And the parameters allow you to input values from the outside world. So whatever you use to deploy your templates, you can provide these parameters from whatever tool you use. So here I've defined a parameter called the storage queue, and it allows me to define that from the outside world. So you see that this particular parameter is of type string, but there's actually a few other types available as well. So we could create a parameter which is an array, an object, a bool, an integer, or the string I used here. And there's also two specialized versions, which are the secure string and the secure object, We will talk about those two specific in a bit, and you will actually see each and every type mentioned here later on in the demo. So the fact that I'm able to show you what types are available here is because I've installed an extension on Visual Studio that helps me write these ARM templates. So there's an extension that you can install to help you out here. Besides the type, I also get to specify the allowed values, which limits whatever I can put into a parameter, and also helps you while working with the template, showing you what you can actually put into the particular parameter. There's also something called the default value, which allows you to make this parameter optional and give it a default value. And you could give a description here, which again would be useful when you start using the template. It would show in the editor and tell you what this particular parameter is being used for. Then, how to actually use a parameter. Down here I defined a resource, and this is how we can actually use a parameter. Using a parameter has been done by using a function, the parameters function, and you use the name of the parameter as its input. It's as simple as that to use it. Alright, so I already mentioned that if you deploy your template, you can specify values for each of the inputs you require. You can also create what we call a parameter file, as I'm showing right here, and that only contains the parameters that you have, and it doesn't contain types or whatever, but it contains the actual values you want them to be. So what I often do is that I create one of these parameter files per environment I have. So here I have a parameter.test file, and then this file contains the values that I want to use for my test environment. And then of course later on I also create a production one and put in there the values that I want to use for production, because on production, for example, you might want to go for a bit more resilient, redundant storage option. So you want to go for a geo-redundant option, probably not for the locally one. But it's more expensive, so you might want to pick this particular one for a test environment. And the parameter files allow you to do that, but still store them in version control, for example. Alright, next we have variables. And variables allow you to store values that you use multiple times throughout your templates and allow you to only specify them once. Or you could also use them to store and specify a bit more complex expressions and have them listed in one place. So you don't have to specify a type or whatever on the variables. It will get that at runtime from whatever comes out of your expression. So again, you just define it with a name. And just as with the parameters, we have a variables function that allows you to get the value of a particular variable by again just giving the name. Alright, so next up, functions. You already saw a few functions coming by in the previous two demos. The parameters one is one, the variables one is one, and also here in the variables one you saw the concatenation, the toLower. All of those are functions that allow you to make your ARM templates more expressive and do more complex things with the templates. And this is a list of the built-in functions that I tend to use a lot. There's a lot more built-in functions that are to your disposal. You can find them online in the ARM template reference. But these are the ones that I tend to use a lot. And we are not going to go over each and every one of them. Most of them will be pretty clear to you. You already saw the parameter one. You could probably guess what an if could do for you. That would return a Boolean value, and you can make decisions based on that. What I do want to tell here is that most of these functions you can use on any of the scopes that we talked about earlier. So you can use all these functions at subscription level or at a resource group level, for example. There are a few exceptions to that. And that is, for example, the subscription function. That one gives you information about the subscription you're currently deploying to. But you can probably imagine that if you deploy something to a management group, that doesn't have subscription information because it's somewhere higher up in the hierarchy. So you can't use the subscription function at that particular level. You can use the subscription level where you deploy to a subscription or to a resource group. So most of them work at all the levels, all the scopes, but some of them do not. So besides the built-in functions, you could also create custom functions for yourself if you want to. And you do that in the functions section in your templates. So you have to specify a namespace, and then you have to specify the members, which are the actual functions that you write. So here I wrote a function called unique name, and I can give my functions parameters so they can have input, and of course I need somewhere to specify what needs to come out of this particular function, and that's what I can do in the output section. So I have to specify the output type, which in this example is a string, but you can use all the other ones, and I have to specify a value, an expression, which I will be returning when I call this particular function. And then in my templates, I can use them in this way. So I can say namespace, dot function name, and then put whatever in there that needs to be put in there as a input parameter. So that's how you could use them. And I find them especially useful when I need to do a thing multiple times within a template and it needs different input all the time. Then I go around writing my own function. But there's one thing about functions that makes them less valuable, and that is that you cannot share your own custom functions across templates. So if you have a function and you want to reuse that in another template, you simply have to copy and paste it. You can't reuse them. So that means that they have a bit more of a maintainability problem there. But still you can create them, and they're quite useful. Alright, let's go to probably the most important part of the ARM template, and that is the resource section. That is where you actually define your resources. And I've created two down here. This is a server farm, and down here I'm creating a web app. So these two resources will create me an Azure web app. There's a few properties on a resource that are required, and you always need to specify one. The type is one of them, and the type consists of a namespace and the actual resource you want to create. You have to specify the API version, it needs a name, and most of the stuff you deploy into Azure also needs a location. There's a few exceptions to that, but general rule is that you need to specify the location, which is the Azure region you want to deploy your resource to. And again, the extension here can help you to find the resources. But you will probably most often use a parameter for it, so you can also easily deploy it somewhere else, do geo-redundancy, etc., etc. So this is how we can simply define resources. And so, as I said, there's a few required properties, and then each resource also has properties that are specific for that resource type. And most of those properties go in an object called properties. So we have properties in properties. I wish they would have picked a different name for it. But so the resource specific properties are being put into a properties object, as you see down here. Alright, to wrap up the basic ARM stuff, last but not least, you could also define what is called an output to return something from your deployment. So where parameters allow you to put something in, values into your templates, outputs allow you to give something back to whatever you use to deploy the template. So if you would use Azure CLI to deploy this particular template, then the value that you return here will afterwards be available in the Azure CLI, allowing you to do next with that value whatever you need. So it needs a name, it needs a type, and it again needs a value in which you specify what you actually want to return. So in this example, I used a resource ID function, and that resource ID function will give you the entire ID for this particular resource, so that you can later on address that resource if you want to, using that ID. Alright, so that's the basic ARM template stuff. Let's go over to the more advanced stuff, and let's see what it's all about. Alright, so the first thing I want to talk to you about is that we have the ability to conditionally deploy a particular resource. you sometimes might find yourself in a situation that you want to deploy or do not want to deploy a particular resource based on a condition. So I, for example, now work in an environment where we deploy all of our resources per client, but sometimes we want to deploy a particular resource for client A, but we do not want to deploy that particular resource for client B. So that's a nice example of where you could use a condition to specify if you want to deploy a particular resource or not. And you can simply use an expression which needs to lead to a Boolean value, true or false. Use an expression to say if you want to deploy the resource or not. And here in this example, I'm simply using a parameter, but you could also do an if equals client is client A, then deploy the thing, otherwise do not deploy the thing, something like that. There's one thing you need to think about when you use these conditions, and that is that the check whether it needs to be deployed comes quite late in the whole deployment process. And that leads to the fact that for example, this parameter down here or the parameter down here still need to result in a correct value. Often when you, for example, have an expression that's based on an array, and an array, for example, could be null, then you still need to make sure that whatever you specify here in other parameters, other expressions, still can resolve to a correct value, otherwise it will throw an error. It will still try to parse whatever you put down here, although this might lead to false. So that is sometimes quite tricky. Alright, now we're down here anyway. What you see here is that on top here I've specified a resource that will deploy me a SQL Server. And down here, within the resources section of my SQL Server, I have specified that I want to deploy firewall rules. So I can actually have parent resources, and then within that I can have child resources. And if you do that, then you get a different way of defining your types and your names. So the type over here is the entire namespace with the resource, so Microsoft.SQL/server. And here I've only specified firewall rules, where it actually is a Microsoft.SQL/server/firewall rules resource type. So you don't have to specify the whole thing when you use that as a child resource. The same goes for the name. You don't have to specify the whole parent naming and child naming whenever you use it as a child resource. So if I scroll down a bit, here I actually created the exact same resource, and down here I did not define that as a child resource, but as a normal parent resource. So you see that I then have to specify the entire type and the entire name, which needs to have a slash in it then, instead of just the simple name and the simple type, what I can do when I deploy it as a child resource. So another thing you see here is that I can define how I want the ordering of stuff that gets deployed. So you could imagine that if you want to deploy firewall rules on a SQL Server, that SQL Server needs to exist first, and then when that exists, you can deploy the firewall rules on top of that. So depends on allows you to specify that order, and you can do that in different ways. So I can, for example, specify the name of another deployment, and it will wait for that deployment before deploying this particular resource. I can use an expression to point to a particular other resource. I can use these two ways of defining it whenever that other resource is in the same resource deployment. If it's not in the same resource, if it's, for example, something that already exists in Azure, then I can use the resource ID function to query that resource, and then it will wait for that resource to exist before deploying this particular resource. Alright, so one thing about the depends on stuff, although I defined the firewall rules here as a child resource, I still need to define the depends on here. It's not something that the resource manager will do by itself. You still need to define this depends on, or otherwise you will get complaints about the fact that you can't deploy firewalls to a non-existing SQL server. Alright, next up, let's talk about arrays and objects. You will often deploy a resource type multiple times. So in this example, I'm going to deploy 2 storage accounts. And what I could do then is simply define 2 storage account resources, and have the 2 deployed in that way. But that becomes a bit clumsy if you have to deploy 10 or even hundreds of resources. So there's a better way to do that. So what I did here, I defined a parameter of type array, which consists of 2 objects that define how I want my storage accounts to be deployed. It's the names, etc., which are in there. And then down here in my resources section, where I define that I want to deploy something called a storage account, I can use something that is called the copy to deploy a particular resource multiple times. So that one needs a name, and then I can have to specify a value for the count. So that will obviously be the number of iterations over the array to create the resource. There's 2 modes to my disposal, both being serial or parallel, which allows you to or deploy all the resources just at once, or deploy the resources one by one. Or if you use the batch size, you could actually say deploy 2 resources at a time, deploy 3 at a time, deploy 4 at a time, etc., etc. That's because sometimes the storage account could be deployed together because they're independent. But sometimes you want to deploy a particular resource multiple times, but the parent resource which you deploy to might not allow you to do that. So then you can go for the serial approach here. And then down here, you can use the CopyIndex function to get to the current index in your particular array, which in this case is an object. So I can use the dot notation to get to the actual value within the object on that particular index within my array. So I already told you that you have to specify a name for the loop, and you can then again in other resources use that name in your depend on. So you obviously can't use the name here on the resource itself, because that will change for each iteration. That will have to need a unique name, but you can then still use the name of the loop in your depends on to actually wait for that. Alright, so in the previous example you saw me using the copy statement to deploy multiple instances of a particular resource. But you can use the copy on other stuff as well. So here I'm using the copy within the property section, but you can also use copy in variables or use copy in outputs. And here I can use them, as you can see, in the property section of a resource. Here I'm deploying a virtual network, and a virtual network can have 1 or more subnets. So I can again use the copy command to real-time create me the array of subnets that I want to deploy. So it needs to have a name. It again needs a count, and then in the input property, I can specify what should be put in the array, the subnets array, for each iteration. So the end result of this copy command will be that I actually have a subnet property, which is an array which has one or more of these input sections defined, and that will then get deployed. So the copy over here is an array in itself. So this here, the specification here of this particular subnet one, that's an object. The copy accepts an array, so I can actually do more than one over here if I wanted to. Alright, next up, you will see that once you start creating these ARM templates, that they quite quickly become quite large. That also has to do with the way you have to build them and the JSON language in itself, the JSON specification. So they become quite large quite quickly. And bigger, larger templates are also harder to reuse in different scenarios. So what you might want to do is split up your template into smaller parts so they're easy to maintain and you can do better reuse of them. But then you need a way to glue them together again while you're going to deploy those templates. And that's where linked templates come in. A linked template is, as of the other resources that we saw earlier, just a resource type. But this time, it allows you to specify a URL to another template. So in this example, I'm pointing to a storage account.json file, and that one will just deploy me a storage account, and I can point to that using a linked template. So the resource you're referring to here needs to be accessible by the resource manager. So what you will often do is put these templates into a blob storage account and then use a SAS token on it to still protect your resource. But that will at least make sure that your resource manager will be able to access that particular template. So these linked templates can have parameters. So this is how you specify the input for the storage account parameter. And they can also have outputs. So if that linked template, that storage account template, would output anything to me, then I can use the reference function to reference my linked template and then use the output object property to get back whatever was returned from the linked template. You will see them being used later on while we go to the more real-world demo. Alright, so next up is how would you handle secrets within your ARM template deployment. There's various ways to do that. And when I talk about secrets, then I mean stuff like passwords for your SQL Server or your storage account key, for example. So the first thing you could do is use a parameter of type secure string. You already saw that in the first code snippet we looked at. So the secure string is a specialized version of the string, as is the secure object, and it's just a string, but the resource manager will make sure that the value of it will never be shown anywhere. So you won't be able to view the particular value in the Azure portal. It will not be stored in any log whatsoever. So it allows you to input a secret into your ARM template, and you could, for example, then store that secret as a secret variable in Azure DevOps and pass it when you're gonna start your deployment. You use that just as a regular parameter, so there's just the parameters function like we saw earlier. Let's quickly enable the resource manager extension here. That looks a lot better. Alright, so a better way probably is to use Azure Key Vault to store your secrets instead of storing them in Azure DevOps, for example. You can do it as well. You can reference Key Vault. So here again, I have a parameter defined, admin password, but I'm not defining the value or the type here. I'm having a reference to my Key Vault. And what I need to do for that is that I need to specify the key vault that I want to use, and I need to specify the name of the secret in that particular vault that I want to use. So here I have to specify the entire ID of the resource. So we talked about the resource ID function before. This is the syntax that the resource ID function would normally return for you. So it's the entire build up towards your resource. So it's the subscription in which resource group does that live, what is the provider, and then what is the actual name of the vault, the resource you are referring to. So this is what such a resource ID looks like. And you have to specify the full thing here. And that is because most of the built-in functions we talked about, you can use them here in the parameter section. But that's not true for all of them. The resource ID function is one of the few functions that you are not allowed to use here in the parameter section. So you can't do that here because that won't work at runtime. It will simply throw you an error. The same goes for example, the list function on a storage account, which allows you to get a storage account key. That also will not work here in the parameters. So you have to hard-code it, specify the name of the vault. It isn't that convenient because that doesn't allow you to reuse this particular template anymore because you've just hard-coded a specific vault. So to overcome that, we could again go to a linked template and then, as the parameter for a linked template, use the same reference, but this time, since we're not in the parameter section of the template, but we're in the parameter section of a linked template, I do get to use the resource ID function. And the output of that will be identical to the resource ID you just saw, but this time I don't have to hard-code and specify that particular value. So that's various ways in which you could come to secrets in an ARM template. Alright, next up, you will find that once you get to deploy a lot of stuff in your Azure subscriptions using ARM templates, there also are a few things that you cannot do with the ARM templates. And an example of that, which I ran into this week, is that if you want to do kind of anything with Azure Active Directory, that you cannot do that from an ARM template. You have to do that from PowerShell, for example, the Azure CLI. So that's why we have something called a resource type called a deployment script. And the deployment script type allows you to deploy a PowerShell file, PowerShell script, or an Azure CLI script. So you can embed that within your Azure ARM template deployment. And you do that by either specifying your script here inline, or you could refer to your script on a public location again using this primary script URI property. You get to give arguments, you get to use environment variables, and you also get to specify an identity, for example. And the identity you specify here will be the identity used to run your script. So you could give that identity particular permissions that you need to run that actual script. If you don't specify an identity, then the identity will be used of the user that deploys the template. So if you use Azure DevOps, for example, then the service principal you use to deploy your template will be used as the identity to run your script. And what will happen here under the hood is that they will pick up your script, they will start running a container on Azure Container Instances, put your script in it, and then run your script using that particular container. That is, today at least, always a Linux container. So you can't do these kind of scripts on Linux. So if you, for example, want to do stuff towards Azure AD, that's an important thing to know, that you can't use Windows, but have to do Linux stuff. Alright. Another way to come around the fact that you can't do everything with ARM is using what's called extensions. And we have extensions on both virtual machines and we have extensions on SQL. So you can deploy virtual machines using ARM template. That's quite easy to do. But what you then often need to do after deploying that virtual machine is actually do some setting up of that machine to actually get it to work, to get it to do what you want it to do. So you want to run a script on that particular machine, for example, after it has been created. And that's where the extensions come in. There's a few extensions out of the box, but you can also use what's called a custom script extension. And that again allows you to run, for example, a PowerShell file. And the PowerShell file will be run after your virtual machine has been created. And in this particular example, I am using that to install a web server on my virtual machine to be able to deploy a web app. But you can also use that PowerShell script to, for example, hook up to your PowerShell desired state server in Azure and then that PowerShell desired state server will do the rest of the configuration on the virtual machine. But this will at least give you an entry point into that machine after it has been created. So the other extension I already mentioned is the one on SQL. So again, we can't run just SQL statements from an ARM template deployment. If you would want to run SQL statements, you would have to go to, again, the deployment script. What you can do is use an extension on SQL Server, and that extension, for example, allows you to import a database backup which you have stored in a storage account. So that gives you an entry point to your, in terms of data on your database. Then you could use an import for it. Another thing you could do to get a starting point with actually data on your SQL Server is, while you are deploying that, say that you want to copy the contents of another database in the database you are currently creating using this create mode, and then specifying the source database ID. So that's ways to kind of come around a few limitations that you have in ARM templates when it comes to data and working with the actual resources themselves. Alright, I'm gonna skip a few looking at the clock. What I do want to talk about is the new next thing in the Azure landscape in terms of doing infrastructure as code in a declarative way, and that is Bicep. As you might have seen in previous examples on the ARM templates, that they can get quite big, and they're a bit clumsy sometimes in the way that you write your expressions, etc. And Bicep is a new initiative to kind of overcome that, to make it a bit easier to write ARM templates, because the learning curve there is sometimes quite steep. So the script you see here will create a storage account which has parameters just like we used in the ARM templates. You can use var to create a variable, and this down here will then create a resource, and again we can have output just as we can in ARM templates. And if you then want to deploy this stuff, you have to use a command line tool. Of course, there's a command line tool for it. And the output of that command line tool will be, again, an ARM template. So Bicep, in that sense, it's nothing more than a transparent abstraction on top of ARM templates. But they will still transpile into an ARM template that contains whatever you specified in your Bicep file. And so if you're going to deploy your template, you're actually going to do that in the exact same way as you're going to deploy your ARM template, because the result of a Bicep build, so you will, is an ARM template. It's currently not general available, not ready for production yet. That will come, but it's not yet there. There's a few limitations. One of is, for example, you can't use loops, so the copy command isn't available yet in Bicep. So there's a few limitations there. That probably will stop you from using it for production scenarios today. Alright, having gone through the more fun stuff, let's look at a bit more of a real life situation, how you could build up your infrastructure as code solutions and how to deploy them to Azure. So let's start with this little picture here and talk a bit about how you could structure your infrastructure as code solution. So if your infrastructure isn't that big, you are probably best off with having just a single file and put your infrastructure resources, your templates in it. That's probably easiest to deploy, easiest to maintain, etc. But once your infrastructure becomes bigger, those files become hard to maintain, and they're quite hard to reuse across different clients, reuse across the company, for example. So what I then tend to do is split my templates into different types. So let's go through that. So what I always do is that I create a main template. That's my entry point for deployment. So that's the file that I will address when I want to deploy my template. The main template will then call another template using linked templates or linked deployments. And I have two versions of that. One is being called nested template, and the other one I call composed templates. The nested templates are my building block templates that I can deploy. Those are templates that do just one particular thing. So here in my nested folder, I have a few very small templates that just do one thing. Here, for example, is the app configuration template, nested template. This will just deploy an app configuration into my Azure environment. And then those nested templates will be used by either my main template or my composed template to glue that together and come to a real infrastructure. So this composed template over here might, for example, be calling a view nested templates, which create me the app server farm, which create me the Azure web app, and maybe I want to use application insights. So those three things could be a nested template, and then a composed template will glue those together and create actual infrastructure. So to dive into that a bit more, this is my application main file here. It has a few parameters, it has a few variables, and then the most important part here is the definition of the resources. So as I mentioned, in this main file you won't find actual resources. The only resource you will find here is that of type deployment, which is the link template stuff. So this one, for example, will call a nested template directly. It will create a key vault. Next up, I will add a few access policies to that particular key vault to allow applications and people to use that. Here, again, a nested template call to create the app configuration, but then I'm using a composing template which will deploy and create my web apps. So if we quickly look into that one, that's this particular file, then you see that this one will again be using nested templates to create application insights. It will actually create my server farm, and it will actually create my web app. So that's how I come to a structure of templates which allow me to reuse them across the organization, across customers, etc., etc. So when you then want to deploy that stuff, then there's two things we need to do. We need to make sure that the templates are available for the Azure Resource Manager to use. So, as I mentioned before, I'm going to copy them to the blob storage. And then the second phase is to actually deploy those particular templates. So, let's quickly move over to Azure DevOps to see what it looks like. I defined this particular deployment pipeline in YAML, but I find it a bit easier to talk through it around here. So there's two stages in this deployment. The first one is publish my templates, store them in a storage account basically. And then the second one is deploy the templates. So what will happen here is that all the templates will be stored in a storage account, in a container which has the ID of this particular build. And then while deploying then I get to deploy this particular template into my Azure environment. And one of the things I do there is that I replace a few tokens in the files. And let me quickly go back to my demo code here. So this is the parameter file that gets deployed. And using this particular syntax down here, I get to, while deploying this template, replace these values with values from Azure DevOps. So I can make this environment will be the test environment, production environment, etc. That will be replaced by the pipeline over here in this particular step while deploying. And then the stuff will get to be deployed to Azure and end up in this particular resource group, as you see here. One last thing I want to point out to you is that once I start deploying this stuff and I need to monitor what's going on, I always tend to go to this particular blade over here. If you are on a resource group, you can hit the deployments down here, and you go to the deployment history on this particular resource group, and that allows you to go into the details of all the deployments that happened on this particular resource group. And especially when there are errors, when something goes wrong, I find the details that you get here much more useful than the details you get back in the Azure DevOps pipeline. They are a lot less readable than the ones you actually get over here. So I can always have a deployment and the Azure portal open to monitor what's going on and to be able to see what's failing, etc. Alright, with that, let's go back to my slides. Thank you all for attending my session, and let's see if there's a few questions.
Actually, Erwin, we do have a couple of questions, but I don't think it's necessary for you to use your screen with answering the questions. So I'll invite you to join me at the table here. Yep, and in the meanwhile, I forgot to mention the winner, and actually the winner of a YubiKey of the second question, and I believe that Henry's question. So that's Teun van Schagen. Congratulations there, you just won a YubiKey. Make sure that you follow @4Dotnet on Twitter, and we will contact you. And I see that now Erwin joined me at the table, so we have a couple of questions, and I believe that you already answered some in the remainder of your session.
All right.
One of the questions is, I suppose you can reuse custom functions that you've written in your own template?
You can reuse them within the template that you wrote them in. You cannot reuse them across templates. So you can't. So if you define them in one template, template A, you can't use them in template B.
Yeah, that makes sense. And there's one question by Bicep. You ask, can you parameterize things like subscription IDs and stuff?
Sure. Basically, all properties on any resource, you could create a parameter for it and put it in there at deploy time. Yeah, definitely.
All right. Final question is by Martijn Kamphuis. Can you define which ACI resource you want to run your deployment script on? Like, can I run my own ACI instance?
That's a good question. You actually can. I had to do that last week actually. So yes, you can. You can create your own, and then there's a property in the deployment script resource that allows you to specify that. This week I had to do that because I had to access a SQL database which was actually not publicly available. So I had to enable networking on the Azure container instance to be able to access the database from the deployment script. So yeah, you can do it.
All right. So, and do you happen to have a question for our audience?
I do. And the question I have is one that I already answered in one of the first slides in my session. And that is, what other ways are there, besides the templates we talked about today, to address the Azure Resource Manager? So what other ways to do that are available at your disposal? Good
question. All right, thanks a lot, Erwin. And I see that the question police just came in with the last winner of Irina's question. Irina asked a question about gRPC, and I see that Gustavo is the winner of that. And Gustavo also wins a YubiKey, so congratulations with that one, Gustavo. That's at GoSantos88, that's your Twitter handle. So congratulations.